Good morning, everyone. Welcome back to Coding Hives. This is Rasina with you. So, today we are going to do an interesting problem in programming, that is finding the first n prime numbers. So, I will explain what prime number is, and we look at two simple methods to find them, and I will explain the code in detail. So, as you know, a prime number is a number greater than 1 that has no divisors other than 1 and itself. Some examples of prime numbers, as I wrote here, 2, 3, 5, 7, and 11, etc. So notice that none of these numbers can be divided by any other number without leaving a remainder. So our task here is to find the first n prime numbers, which means if you want, say, first 5 prime numbers, our output should be something like 2, 3, 5, 7, and 11. So we will start with a basic method, then make it a little bit more efficient. So the basic method is a trial division method. Here I am going to write a function to check a number is a prime or not. Okay, so as you know, a prime number starts with the 2, right? If the number less than 2, we can simply say it is not a prime, right? So we can simply return it as false. Next, we can loop from 2 to num minus 1 and check the divisibility, right? So for that, I can do something like this for I in range of, I need to start from 2, then ends with the n minus 1, I mean num minus 1, right? So here we can use num to get till num minus 1, right? Then I can do something like if num mod I equal to 0, that means it is a factor, right? So we can simply return false as this number is a prime, so false. Okay, otherwise it will go for the next number till the loop exit, and if it go for all iteration and it pass, then we can simply say it as a prime number and we can return true. Clear? So this is the function to check a number is a prime or not. Okay, so actually our problem is not to check a number is prime or not, we need to find the first n prime numbers, right? So for that I will write a function def first n prime numbers. Okay, so here n is the count. So here initially I am declaring an array, I mean a list prime. Then our starting number is 2, right? So I'm initializing that also. Number is 2. Then I need to go for a loop. Like I need to check the length of the primes array should be 5, right? Like I mean it is less than n. So we can check some condition, something like while length of primes less than n. Okay, so this is a condition. We want 5 numbers or 6 numbers, whatever n is there, that much numbers we want in that primes list. Okay, so that is a condition. Here we need to check, like if this number, right, we have a function to check the prime. If prime of number, if it is true, we know this is a prime number. At that case, we need to add that number into this primes list, right? So we can simply append. We have append function. We need to append this number, right? Otherwise, like if it is not prime, we need to go for the next number, right? So for that, I am incrementing the number by 1. Clear? So this process will done till the limit reaches. So at the end, we can return this primes list, right? Now inside, I am calling this function first n prime numbers, and I want 5. Okay, so you can see here we will get output as 2, 3, 5, 7, 11. Now I will explain this code again. So here this is prime function checks if a given number is prime by testing a divisibility. Like if the number is less than 2, we can return false because 0 and 1 are not prime. Next, we loop through the numbers from 2 to num minus 1, and if any number divides in this number evenly, we know it is not a prime and we can return false, right? If we find no divisors, that means we return true, meaning that a number is prime, okay? Then the next function is first n prime numbers, right? So this function finds the first n prime numbers. So here we initialize an empty list primes to store our primes. We use a while loop that keeps running until we have primes. Then for each number we call is prime to check if it is prime or not. If it is, we add to our list of primes. Okay. So this is our code and we got the output as expected. Now, let us improve this code a bit to make it faster. So, instead of checking here all the numbers from 2 to num minus 1, we only need to check divisors up to the square root of the number. Why I am using this square root concept is like if a number has a factor than its square root, then it must also have a factor smaller than the square root, right? So for example, if 36 has a factor of 6, right, which means it's the square root of 36. So then any other factor pair would involve a number of smaller than 6, like 2 and 18. So checking up to the square root is enough in this case. So here for that I can change only this line of code. I can change something like for I in a range of, we need to start from 2 but end condition is till the square condition, like int math dot square root, there is a function sqrt, then our number num. So in this code, I mean in this line of code, this math.sqrt of num calculates the square root of this number, okay? And this int math of square root num converts the square root to an integer, okay? So we get only the old numbers. For example, we are getting something like 5.6, it will convert as 5, okay? Now adding 1 means it ensures that we check up to the exact square root if it is an integer, okay? So that is the case we are dealing here, and the remaining all same as before only. So the rest of the code remains the same, but this small change makes it much faster for larger numbers. And that's it for today. We learned two simple ways to find prime numbers, starting from a basic trial division and moving to a square root optimization. Both methods are helpful depending on the size of n you are working with. Okay, I hope you got a clarity about how to find the first 10 prime numbers. Thank you for watching. Have a nice day.